in the universe. Very good. Okay. What are the factors upon which gravitational force depends upon? Like since it is present everywhere, every two objects are attracting one another. So what are the factors upon which the magnitude of the gravitational force will depend upon?
So the mass of both
Exactly.
objects.
Mass of the objects. Very good. If a object is very huge in size, like a planet, right now, so then it will be having a significant amount of gravitational force. Okay. Then electrostatic force, tell me, what is the nature of electrostatic force? Like, is it attractive, repulsive, or both?
So both.
Both. Okay. On what factor will it depend? Like whether there's going to be attraction or repulsion between the objects? What does it depend upon?
So like it is the attraction or repulsion of two objects when
Hmm.
it's the attraction or repulsion of two objects when they are rubbed over one another of similar charges. Like yeah.
They'll be repelling each other if they acquire similar charges, positive, or negative. Then they'll be repelling each other, right now. But
Yes.
if they have the objects have opposite charges, right, and then they are going to attract each other. That's the thing. Okay. Okay, magnetic force, that is quite simple. Let's do some questions. All right now. So first question is, list two examples where a force causes a change in the shape of an object.
So taking a football and like squishing. I mean tearing the page.
Okay. And
So I gave two examples. Okay.
okay. You can think of few more examples, like stretching a rubber, right?
Yes,
That is
sir.
also an example. Okay. Explain the difference between contact and non-contact forces and provides one example for each.
Okay.
Hmm.
So contact forces are those forces which require physical contact with each other to bring more necessary changes. For example, muscular force.
Hmm.
Non-contact forces are those forces which do not involve physical contact with each other, but they act upon the objects between them
Hmm.
through the space present between them.
Okay.
For,
Okay.
for example, electrostatic force.
Hmm. Hmm. Okay. So a force that is exerted only when two objects are touching each other, it is called as contact force, right? So you have muscular force, frictional force, etc. While a non-contact force is a force that one object exerts on another when they are not touching, when even if they are away from one another, right now. And examples are magnetic force, electrostatic force, and gravitational force. Okay. In the exam, definitions may be asked like the question might be asked to define what is muscular force, what is electrostatic force, and gravitational force. So have you prepared the definitions? Hey Hanvi, how are you?
Yes, sir. Just today I learned the question answers.
Oh, that's good. Good. Okay. So quickly give the definitions. Explain like how do you define muscular force?
So force exerted by muscles is called muscular force.
Force exerted by muscles is called as muscular force. Right? Okay. Then how do you define frictional force?
The force created when two objects are sliding over each other, which opposes the motion of the
Hmm.
object, is called a frictional force.
Very good. So force which always opposes the motion of one body over another body, that is frictional force or simply called as friction. Hanvi, I suppose you can hear me. Uh, don't know. Okay. And what about magnetic force? Give a simple definition.
So a force exerted by a magnet on iron objects is called magnetic force.
Or basically on magnetic objects, because not only iron is magnetic, but even cobalt and nickel are also magnetic objects, right now.
Yes, sir.
Getting it? Then what about the gravitational force?
So force existing between two objects due to their mass is called gravitational force.
Hmm, Good. So as Newton said that every object in the universe pulls every other object with a certain amount of force. Right now, every object in the universe pulls every other object with a certain force. So the pull exerted by objects that have mass is called as gravitation force. It is important to mention that these objects must be having some mass. Then they will be applying a pulling force on every other object in the universe. Getting it now? So
Yes,
that is
sir.
gravitational force, right? And it's the gravitational force between the sun and the earth which holds the earth in its orbit around the sun, right? So what will happen if there were to be no gravitational force between the earth and the sun? Hanvi, you're there in the class, no? Turn your camera on.
But the network is really bad.
Okay, okay. How are you doing?
Fine, sir. How are you?
Yeah, I'm also doing good. Good. Okay. You have joined the class after some time, like you were absent in few classes, I think.
Yes, sir. When do you want me to join the class?
No, no, I was saying that in this regular batch, you were absent. The last time we have we had a class, it was on Thursday, I suppose, like on 5th of June, I guess. Did you join the last class?
Thursday I was not home, sir.
Okay. We try to be regular in class. Okay, na, Hanvi? Hmm.
Okay, sir.
So I had asked question, both of you try to answer this. What will happen if there were to be no gravitational force between the Earth and the Sun? What will happen?
We would fly in the sky.
Fly in the sky, or basically Earth will drift into some random direction into space,
Away.
right now? Okay. And it's the same gravitational force between the Earth and the Moon, which holds the Moon in its orbit around the Earth now, right? That's the thing. Okay. Now we have this question which we'll be doing after some time, because to do this question we first need to learn about pressure. Okay, now answer these questions meanwhile.
So in the chat,
Both of you can answer right here in the class. Okay, only two of you are there. So what is force, Hanvi? Yes, Mustafa.
so push and pull both.
That is push and pull both. Good. Next you answer, Hanvi, which of the following is a non-contact force?
Tension.
Non-contact force. No, tension force is a contact force.
Non-contact.
uh,
Friction force. Killer force. Gravitational. Gravitational force.
Gravitational force, very good. Yeah, Mustafa, next.
Uh, to the difference between two forces.
Very good, no? Because when you are taking an object and we are like we have a given object and forces are being applied on that object from two different sides, right? So the net force, the overall force acting on that object becomes the difference of the two. Like suppose I'm applying a force of 10 Newton on this object and there's another person who is pushing it with a force of, let's say, 12 Newton. So what will be the net force? F net?
2.
2 Newton exactly, no?
Two.
So that will be 12 Newton minus 10 Newton, that is 2 Newton. Good. Okay, next, which of the following is a contact force? Is Hanvi? Yes. By the way, does Earth also behaves like a magnet? Is there a magnetic field of Earth also? Does
Yes, sir.
Earth also has a magnetic field? Good. Yeah, fourth question. Which of the following is a contact force, Hanvi? Gravitational force, magnetic force, frictional force, or is it electrostatic force? Mustafa, fifth question. Which of the following is a non-contact force? I think this question has been repeated actually.
Yes, sir. Gravitational force.
That's gravitational force. Yeah, and for the fourth one,
So
what's the
frictional
answer?
force.
That is frictional force, no? And we basically what we have learned about the frictional force. Now, this force comes into action when two objects are in contact with each other. Right now, like for example, we have muscular force. If I have to push some object or pull some object, I cannot push or pull it until and unless I apply muscular force on it. Until and unless I use my muscles. So muscular force is a contact force. Then we have the example of frictional force. Whenever an object would be sliding over another object, right now, so the surfaces of two objects comes in contact with each other. There are some minor irregularities on the surfaces of the objects like this. So when one object is being tried to slide over another object, so these surfaces which have a small irregularities in them, they kind of interlock with each other. And as you try to slide one over another, it resists. So thereby, as you are pushing the object in this direction, the frictional force will be basically resisting it in the opposite direction. So that is frictional force, which is again a contact force. So option C is the right one. So here we have completed everything about the force. Now we are going to learn about
Sir,
pressure.
what is
Yep.
motion?
Mhm.
My ma'am in school asked like to
Mhm.
answer the simple questions. I
Hmm.
mean, my ma'am in my tuition asked
Hmm.
the simple question.
Like what is motion? Like when an object is said to be
That
in
is
motion.
what's. I mean, what is motion?
Good question. See, a simple but a good question. See, when an object is said to be in motion now, like an object is said to be in motion when its position keeps changing relative over time in relation to a reference point. Getting it? Like an object will be said to be in motion if it keeps changing its position with respect to time and a reference point. What do I mean to say this? Let me repeat the definition once again. Listen carefully. An object is said to be in motion if it keeps changing its position with respect to time and a reference point. So suppose I have one object in my hand. Suppose it moves from point A to point B, right? So it must have taken a very small fraction of time to move from this point A to point B, right? No, although it will be of just a small fraction of second, but it has taken some time to
Like,
move
can
from.
you answer it in like simple words?
Yeah. See, try to understand it in the following manner. Like suppose you are,
What, sir?
suppose that you are at a bakery shop. Okay, no? You are at a bakery shop right now. Let us suppose. Okay, Hanvi. Now from the
Bakery shop.
yeah, suppose you have gone there and you are at bakery shop, and from the bakery shop now you are going to move back to your home, right? From here you are now going to move back to your home. Okay.
Yes, sir.
So these are two different places, place A and place B, first
Yes,
place and
sir.
second place. So when you will be changing your position, when you're going to move from bakery shop towards your home, it will take you some time, right? It is going to take some time. Like the moment when you checked your clock, when you checked your watch, when you were in the bakery shop, just before you started walking, let's say the time here was 10 a.m., right? And you started walking, and when you reached your home, now the time was 10:05 a.m., right? So it took you about 5 minutes to go from bakery shop to
Yes,
your
sir.
home, right now.
Yes, sir.
So
The
you will
time
be,
and the speed taken is known as motion.
let's forget about the speed right now. That's a different thing right now. Basically, the thing is that you will be said to be in motion because you have changed your position right now, because you have changed your position from bakery shop to the home, and it took you some time, right? It took you some time. Getting it or not?
Yes, sir.
Okay, so the simplest definition of motion is that an object is said to be in a state of motion if it keeps if it changes its position with respect to time. Right now, like 5 minutes ago, you were at the bakery shop. Now 5 minutes later, you are at your home. So you have changed your position
Yes, sir.
with the changing time. That's the thing. Now you can include one more thing, like a reference point, like a stationary object. Okay, now like the moment you started to walk. So you are walking, you are in a state of motion, but there are so many objects nearby you which are not moving, which are stationary, like the trees, like the this bakery shop. Will it be able to move from one place to another? No, it's fixed into the ground. So this you can take as a reference point. Getting it? This can be taken as a reference point. Reference point is basically any non-moving object, like a stationary object that is not going to change its position. Getting it or not? Or you could also take the examples of the trees nearby the roads. The example of that can also be taken right now. So an object is said to be in motion when it keeps changing its position, when it changes its position from one place to another, with respect to time, with respect to time and reference point, like the stationary objects. Like you see that when you are moving, right? When you are moving, so nearby objects are not moving, like they are stationary. Like the tree, the buildings, they are stationary now. So when you compare their position with them, you will see that you have moved ahead, but that object is at the same spot. You have moved ahead, but that object is at the same spot. Getting both of you what I'm trying to say?
Yes, sir.
A little
Yes,
bit
sir.
confusing, huh?
Yes,
Okay. Let me give
it's
you
a
the
little
simpler definition.
confusing.
An object is said to be in motion if it changes its position with the changing changing time. Like right now, for the last 20 minutes, I have been sitting on the same chair, right? Have I gone anywhere? I have been on the same spot
No.
for the last 20 minutes. So right now I am at rest, right? I am at rest. But if I were to walk in
Yes,
my
sir.
room, right, in this duration of 20 minutes, if I were to be were walking in the room, then I would have been in a state of motion. But right now I am in a state of rest. Although the time is passing, the time is changing, but my position is not changing. So when both position is changing and the time is obviously changing, it's passing. So along with the changing time, if the position also changes, then that object is said to be in a state of motion. Hope that is clear now. Okay. I suppose now you're in a position to answer this question to your teacher next time she asks you. Right, Anvi? Okay. So now we are going to talk about pressure, right? So pressure in simple words, like pressure is produced when a force will be acting on an object, right? In most of the cases, an object exerts force on another object by making contact with it or by touching it, right? So we are going to learn and we are going to describe how the effect of force applied by one object on another object will depend upon the area of contact between the two objects. Okay? Like how much of force I'm applying on a given object, right? First of all, it depends upon my strength, right? It depends upon the strength, it depends upon the friction, etc. But it will also depend upon some other factors also. Right? Like it will depend upon the area of contact between the two objects. So that will be further giving us the definition of pressure. Take an example, like if you are pushing hard on a piece of wood with your thumb, like you have taken a piece of wood, okay, like just a small piece of wood you have taken like this, and
Okay.
in this you are trying to push your thumb like this, suppose.
What is that yellow thing, sir?
That is basically a sorry, it's a piece of wood. Okay,
A
you have
wood
taken a small
piece.
piece of wood, yeah. So you are trying
Okay.
to you're trying to you're pushing hard on a piece of wood with your thumb. Does the thumb go into the wood? Will it go into the wood?
No.
No. But
No,
suppose
because the wood is very strong.
exactly, it's quite hard and tough, right? But if we are pushing a drawing pin, let us suppose drawing pin, right, like this. Now you have taken a drawing pin, suppose, and that you are trying to push with your thumb, suppose. Getting it? On that same piece of wood. Now, although your thumb won't go into the wood, but what about this drawing pin? Will that drawing pin go into the wood?
Sir,
Yes.
depends on how much force you apply.
Yeah, although it depends. Like I'm not just laying my hand on it, I'm actually pushing it. Right now. So if we push a drawing pin into the wood with the same force, like with the same amount of force, let us suppose I was pushing it with a force of 50 Newton, and here also I'm pushing it with the same magnitude. That is again 50 Newton. Right? So with the same force applied over it, I will be seeing that the drawing pin will be going into the wood. So we have two observation here. Like we have an important observation in this activity. So we observe that our thumb does not go into the wood directly because the force of thumb is falling on a large area. Now, let me highlight this area in red. Look at this. This force is acting on a larger area, but here the force is acting on a very small area, isn't it? Yes, Hanvi. Yes, Mustafa?
Yes.
Right? So the drawing pin goes into the wood because of the sharp tip of the drawing pin, and the force of thumb is falling on a very small area of the wood, due to which the force per unit area, listen carefully, force per unit area on the wood becomes very large. Okay, now force on a small area, on a small unit area becomes very large. That's why it is going into the wood. Is that much clear so far? Right now?
Yes, sir.
Now, in other words, what you can see? You can see the force.
Pressure is the amount of force you apply on something, right?
Yeah, repeat again. Pressure.
Pressure is the amount of force you apply on something.
No, not entirely. It cannot be defined in that manner, but rather pressure is basically the force acting on a unit area of the object. We define pressure as the force acting on a unit area of the object. Unit area, you understand or not? Like suppose, how to explain this? Let us suppose now that I have this sheet of paper in my hand. Okay, I just understand I have a piece of wood in my hand. Let us suppose a thick wood. So it will be having some area. In mathematics, you guys understand about unit area now? In maths, you would
Yes.
have learned about unit area.
Uh,
Uh-huh.
Yes, sir.
Just you would have learned
No,
about,
sir.
no, okay, let me explain. Unit area, unit fraction, etc. Right? So unit area is basically like 1 square centimeter, 1 square meter, 1 square millimeter, like that. That's the unit area of it. Getting it both of you know.
Yes, sir.
Hanvi, is it clear to you? Mm-hmm.
No, sir.
No. Oh, how to explain? Let's see. Let's suppose I have got a paper right in my hand. Suppose like this. Okay. Now I will be dividing it into different parts. Let me zoom it out. How many lines are there? How many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9. And now it's 10. Okay. Let's say that this is 10, 10 centimeter, and that is also 10 centimeter. Okay. Let us again divide it further. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, what will be the area of this sheet of paper? Quickly, it's a square,
Sir, side into side, 10 into 10.
and that
100.
is 100 square centimeter. That I suppose both of you know already. Good. Okay. Now, if I were to find the area of this piece, this much of piece, that is going to be what? If the side, the edges, like the side is 10 by 10 centimeter. So this is 1 centimeter, 1, 1, 1, 1, and 1, and 1, and 1, and 1, and 1, like this, right now. Right? So if you have to look at the smaller squares, Hanvi, you paying attention to this now?
Yes, sir.
Good. So if you're looking at the smaller squares here, the side of the smaller squares are equal to 1 centimeter. Right? So what will be the area of this smaller square? Tell me. If the
1.
sides are 1 centimeter each.
1.
1 square centimeter, right now?
Yes, sir.
Hanvi, you getting it, no? 1 into 1 square centimeter. So that is 1 square centimeter. Right? Now suppose on the whole area of this sheet of paper, listen carefully, on the whole area, some amount of force is being applied, right? On the whole area. But if I have to talk about pressure here, so I will look at like how much of pressure is being applied on the unit area, like on 1 square centimeter. Getting it or not?
Yes, sir.
So this is the unit area. Is the concept of unit area now a bit clear to you or not?
Yes, sir.
Hanvi, you're not saying anything?
Kinda.
Kind
Okay.
of, kind of. Okay, okay. Okay, no worries. But if you're understanding it in this manner, no, like just try to memorize the concept that basically Unit area would look like 1 square centimeter, 1 square meter, 1 millimeters, 1 square millimeter, or 1 square kilometer, like that.
Okay.
Okay, now this will become clear when we do some questions. Okay, now when we do some numerical questions, it will be becoming much and much clear to you. So here, what you have observed in this activity, that again we can take another activity also to understand this. Like if you have to cut vegetables using a blunt knife and a sharp knife, which one is easier?
Sharp.
Obviously, sharp knife will cut the vegetables much easier, right now. Although we'll be applying same force on both the knives, but with the help of sharp knife, the vegetables will be cut much easily. Why so? Because there's a small area in contact with the object, right now. This is a smaller area upon which this force is being applied here. But here, the same force is being applied on the larger area, right now. So force that will be acting on a smaller area will apply more amount of pressure than the force acting on a larger area. Also, you would have seen that like porters, the coolie, right? They would be, first of all, they would be placing a piece of cloth on their head, right? Although nowadays the porters are not very common, but in some small railway stations, some airports, they can be found. What they would be doing first? They would be, first of all, putting a piece of cloth over their head, and then they will put the luggage over it, right or no? Why are they doing so? They are doing so to increase the surface area in contact with the luggage. Like this is the luggage that they're carrying over their head, and by putting a piece of cloth over their head, they have actually increased the area. Increased area. So due to this, there will be less pressure of the luggage on their head, and they would be able to carry it much easier. Right now, so it increases the surface area and reduces the pressure, because pressure actually depends upon the area over which force is acting upon. Getting it, both of you?
Yes, sir.
Okay. Can we read the given paragraph? Let me have some water. Okay, Mustafa, you read. I think she's having some network issue.
What is pressure? Pressure is the amount of force applied in a certain area. Imagine pressing a finger on a balloon. If you press with the same force using one finger, the balloon might pop because the pressure is too high. But if you use your whole hand, the pressure is spread out and the balloon is less likely to pop. So pressure depends on how much force is applied and over what area.
Getting it now? So
Yes, sir.
that should give you a general idea about the pressure. Okay. Suppose if a definition is asked in the exam, right now, so you will be giving this definition. Okay, and then you can quote an example also to explain this, right? So pressure is the force acting on a unit area of the object, on a unit area of the object. Getting it? And further, one more thing, talking about like how it gets distributed. So distribution of force, we have just learned that the effect of force will be depending upon the area of the object on which it acts. Right? And the amount, the pressure would be particularly depending upon the area over which force is acting upon. Right now? Okay, so where we learn force acting on a smaller area applies more pressure than the same force acting on a larger area. So we had several examples. Getting it now? So the effect of a the effect of a force depends on the area of the object on which it acts. On which it acts. Are you getting it so far now? Right? And we know that pressure is produced when a force acts on an object now. Pressure will be produced when a force will be acting on an object, right? So pressure here will be inversely proportional to the area. Like if the inverse relation you understand or not, you guys? Inverse relation, like pressure is
The effect of force applied on an object in which acts.
So pressure is inversely related to the area. What does it mean? That if suppose area is less area means more
Pressure.
pressure, okay, no, more pressure, and more area will mean
Less pressure.
less pressure. So it has an inverse relation. Like if it decreases, the other value increases. If it increases, the other value decreases. So that's kind of an inverse relation.
Sir, I have a question.
Okay.
Tell me.
Sir, why railway tracks like put on the you
Got
know,
it.
yeah.
Particularly, that's more common here in India right now. You will see that the railway tracks should be put on giant pieces of cement blocks, and then you have got so many rocks right now. So like giant pieces of sleepers, I think we call them as sleepers, right? So they are also, we have got crushed stones also over which it is placed. Hanvi, you getting it now? What Mustafa is asking, right? Like you'd see that,
No, sir.
not getting it. Let me show you an actual image that saves us. That will save some time. Basically, the same concept is being applied over, so that the force is distributed over a large area. Okay, na? So railway track. Yeah, this is what Mustafa is asking, that why are these crushed rocks placed, right, Mustafa?
Yes,
Right,
sir.
and why these giant pieces of cement blocks called as sleepers are placed over it. Okay, let me explain that. See, it is placed basically to spread the weight of the train over a larger area, or rather spread the force over a larger area. Because if the force were to be spread, like if you guys imagine this, like if this railway tracks were to be directly placed over the soil, there were to be no sleepers. These things that you see over here now, they are called as sleepers. And this right over here, like these things that you see over here, like that is basically crushed stones. Crushed stones. So the railway tracks are placed over the sleeper and the crushed stones to spread the weight of the railway, to spread the weight of the train over a larger area, to basically spread the force over a larger area. So hence less pressure will be created. Otherwise, what would happen? The otherwise, if we were to not use the sleepers and the crushed stones, so thereby, due to the high amount of pressure, the railway tracks will basically get go into the soil, and it will be difficult for the trains to run over it. Got it, both of you?
Yes.
Hmm. Now, talking about the unit of pressure and the formula. So as the definition is, pressure is the force acting on a unit area. What have we learned? Is the pressure is simply the force acting over the unit area. So thereby, as per definition, pressure is equal to force acting upon the area. Pressure equals to force upon area. Getting it, both of you know, right?
Yes, sir.
Pressure is the force upon area. So this formula will be giving the, it also gives us a relation between the pressure, force, and area also. How so? Let me explain. Suppose if the force were to be increased, if force is to be increased, let me rewrite this over here. Pressure, okay, equals to force upon area. Now, if the force were to be increased, so the pressure is also going to increase. Yes or no? Force is increased, so pressure will also increase.
Yes, sir.
Right, Hanvi and Mustafa? But if the area were
Yes,
to be
sir.
increased, then pressure will decrease. Just look at the arrow. The up arrow shows increase. The down arrow shows decrease. So if the area were to be increased, the pressure is going to decrease. All right. Now look at the green arrow here. So if the area were to be decreased, then what will happen? Tell me.
The pressure will increase.
The pressure
Then
will increase.
pressure will increase.
Getting it now? So this
Yes,
actually
sir.
shows us the relation also. Relation between the
If the area is little, the pressure will increase, and if the pressure is more, the area will increase. I mean, the area will decrease.
no, it's actually rather we should be saying about the area, because like the pressure does not determine the area. Rather, area determines the pressure. Getting what I'm trying to say? Like suppose if more amount of pressure is going to be applied over this wooden block, it's not like its area is going to decrease, right? It's the area is going to remain stationary now. It's not going to change, but rather change increasing the area or decreasing the area uh, will decide the pressure acting. Will decide the amount of pressure. You getting it? What I'm trying to say?
Yes, sir.
Yeah. So
It's
this
based on the amount of area.
exactly. Okay, over which force is being applied upon. So this formula also gives the relation between force, pressure, and area and the area. Now let us understand like how do we measure it? Like in what units we measure it? So the SI unit to measure it now. The SI unit, like there's a international unit for measuring every different kind of quantities. So the SI unit of measuring pressure is newtons per square meter, or simply called as Pascal. So the SI unit of measuring pressure is as follows. Suppose we take an example. Okay, try to understand it with one example. Let us suppose that there's a force of 100 Newton acting over a 25 square meter area. That's area, and that is force. So you need to calculate pressure. Like what is the pressure going to be? So the pressure will be simply 25 force or 100. So 4 Newton, and that's per square meter. So you're getting it this value, Newton per square meter. What is this? Newton per square meter. So Newton per square meter, that right here is the SI unit. But like since it is quite lengthy, so we simply call it as Pascal, 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 or in short, capital P and small a. Getting it how we got this value? As you guys
Yes.
already know, the SI unit of force is Newton, and for area, it's square meter. So hence we are able to derive the SI unit of pressure, that's Newton per square meter, or in short, called as Pascal. That is PA. Is that thing clear to both of you? Right?
Yes, sir.
So SI unit of measuring, sorry, pressure is newtons per square meter, and that too can be in short, like we can write it down as Newton per square meter, Newton per square meter, or basically, which is also called as Pascal, 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 in short, capital P and small a. So thereby it is right to say that if you have got 1 Pascal, that is 1 PA, it simply equals to 1 Newton per square meter. 1 Newton per square meter. Right now, so Pascal, it's a very small unit of pressure. Pascal is a very small unit of pressure. So thereby you can have a bigger unit of pressure also. So that will be a kilopascal. So kilopascal is a bigger unit of pressure, and where 1 kilopascal, like 1 kilopascal in short is written as 1 kPa. So 1 Kilopascal is equal to 1000 Pascal. Tell me if this much is clear about the formula and the SI unit.
Yes, sir.
Okay, Hanvi, what about you?
Yes,
Okay, that's good to know.
sir. But I did not understand the after the SI unit. I did not understand pressure. How to calculate pressure?
Okay, let's do some questions that will make it more clear. The
Pressure is
definition,
force by area, right?
right? It is force upon area. Here we're actually talking about the SI unit. Just like you measure mass in kilogram, force in Newton, speed in meter per second, right? Volume in liter, milliliter, distance in meter, kilometer. So there's a SI unit for everything, right now. Anything that can be measured has a SI unit. Okay, we have made a SI unit. So similarly, we can measure pressure now. So for pressure also, we have got a SI unit. So how do we got this SI unit? So I did told you that the formula to calculate pressure is equal to force upon area, right now. So suppose we have taken 100 Newton as force and 25 square meter as the area. When you divide them, you get 4 Newton per square meter. And in short is Newton, this is square meter. So 4 Newton per square meter. So basically the SI unit, okay, now SI unit of pressure is Newton per square meter, or in short, it is written as Pascal. So that's the SI unit of measuring pressure. But 1 Pascal is very small. It's just 1 Newton per square meter. 1 Pascal is equal to just 1 Newton per square
Pressure
meter.
is force by area. So when we have to find pressure, we have to divide force and area, right?
Obviously, we will divide the force with area. Getting it? And kilopascal is the bigger unit of pressure, where 1 kilopascal equals to 1000 Pascal. Okay, before we learned about the pressure in liquids and the gases, let's do some numerical problems. Okay. Suppose a force of 100 Newton is applied on an object of area 2 square meter. You have to calculate the pressure. You have to calculate the pressure.
To 50 Pascal.
Okay, what about you, Hanvi?
Yes, sir.
What's the answer to this? I have written the formula also. Okay, meanwhile, I'm giving a different value also. Okay, now, Mustafa. So now, second question is that a force of 125 Newton is applied, or rather, let's say 725 Newton is applied on an object of sorry 25 square meter. Calculate the pressure. Yeah, Hanvi, you got the answer for the first question?
No, sir. I'm solving it.
Okay, solve it fast.
The
20.
For which one you're
20 for the
getting?
first one.
For the first one, 20. How are you
Yes,
getting
sir.
20? Hanvi, you know the values are 100 Newton and 2 square meter, right?
100 divided by 2, right?
Yeah, obviously. 100 divided by 2. That's going to give how much?
Which is 50. 50.
Yeah, 15. No. So thereby your answer should be 15 Newton per square meter, right? Or simply 50 Pascal, right? Okay, if you're getting your answer in the following manner, then it is correct. Yeah, next question, what you are getting, Mustafa?
The 29 Pascal.
29 Pascal. Okay, Hanvi, you also do the second question. Okay. Now take one more question. A force of 15,000 and 1560 Newton.
752 divided by 25.
Yeah, obviously. On an object of, in this case, let us say that 78 square meter. You have to calculate the pressure, but the twist is you have to calculate the pressure in kilopascal. I'll be giving a hint as well that 1 kilopascal is equal to 1000 pascal. Okay, Hanvi and Mustafa. So that's the question.
Sir, I'm getting in decimal form.
For the second question,
Oh,
no. How are you getting it in decimal? You should be getting actually 29. Huh? Hanvi, you need to strengthen your maths actually. Look, 725 has to be divided by 25. Okay, first of all, I'm going to take 25 to the 50. So there I'm having 225 over here. Then 25 times how much will be equal to 225? 25 should be multiplied by what number? So you get 225. Tell me quickly. 25 times 9s are? Yes, Anvi? 225, no?
9 5 so 45. Yes, sir.
So 25 9s are 225. So thereby, my answer to the question is 29, no?
29 Newton.
Per square meter. Okay, no? Or 29 Pascal. Because Newton per square meter, in short, is called as Pascal, isn't it? Getting it, Hanvi?
Yes, sir.
Okay. No need to worry. You're trying. That's a good thing. Okay, no?
I got the answer for third question.
Tell me the answer.
0.0220 kPa.
0.
020.
0.020.
Yeah.
Okay, kilopascal. Okay, let's Hanvi, you also try doing this third question. Okay, now you also try doing this question. Now, meanwhile, Mustafa, like yesterday we had this class. Unfortunately, not got the time to share the PPT. Okay, now I'll be sharing it after the class.
Okay.
So you answer some questions from the synthetic fibers and plastic. Hanvi, this is not for you. Okay, this is for Mustafa only. You don't have this chapter in your syllabus, I think. So your answer to me, but like, how is rayon different from the silk? Like, how is rayon different from silk?
Sir, rayon is made up of artificial products, while silk is made comes from the silkworm.
Okay.
Sir, rayon is made of coal, air, and water.
Rayon is,
No,
repeat again.
sorry, nylon is made of coal and water.
Hmm. I have particularly asked about rayon.
Sir,
Rayon,
rayon
that's
is
the fabric.
synthetic, and sir, rayon is synthetic, and silk is natural.
Good. So one is a synthetic fiber, while another is the
Natural.
natural fiber. Good. Okay. Also, you know that rayon is not fully synthetic. Why?
Sir, its monomer. So it uses cellulose, I think.
The monomer is cellulose. Basically, it uses the wood pulp. Right now, wood pulp is used as the base material, and then like sulfuric acid is added into it. Some other things are added to make it into a fiber. Okay. Then tell me, what are the two types of plastics?
So thermoplastic, a thermosetting plastic.
Okay, give example of each.
thermosetting plastic, bakelite, and thermoplastic uh, PVC,
PVC, PET, right? Polythene,
polythene, polystyrene.
yeah, polystyrene. Okay, particularly the example, there's one more example of thermosetting
So
that is used to make
bakelite, and
melamine. And
melamine.
this one more, Teflon, I think, right?
Yes, sir.
That's Teflon. Okay, particularly a coating of Teflon is done on the clothes of firefighters. Okay, na? Yeah, let me get back to the third question now. Hanvi, you done with this?
Sir,
Yes,
coating.
sir.
Sir, coating of melamine is done on firefighters, right?
Coating of melamine. Coating of melamine. Yeah, actually, you're correct. Coating of melamine is done. Yeah. I forgot. Okay. Coating of melamine is actually done. Oh, okay. Although Teflon is also fire resistant, right? Teflon is also fire resistant, isn't it? Because
Yes.
it has also several uses. Getting it like Teflon, particularly, is the same material that is used in the non-stick cookware, right? Where it is used. Where I was telling you that there are some harm of using non-sticky pans, non-sticking cookwares. It has some bad effect on our health. Okay, yeah, getting back to this question now. So pressure equals to force upon area. So let us first of all divide them. So that is 1560 Newton upon 78 square meter. Hanvi, you have done anything in this question? You got any value?
What's sir?
Third question. Any progress in this? No. So that's
Sir,
20.
your voice is breaking.
Actually, it isn't, but you are having some network issue, I think. So that's 20
No,
Newton square meter or 20 Pascal.
I copied this question, sir. What were you asking?
I was asking whether you got the answer or not for third question.
Oh yeah.
What's the
No,
answer?
sir, I did not get the
You
answer.
haven't got it. Okay, see, right now the pressure is 20 Pascal, which I have got. 1560 divided by 78. Okay. Now the question is asking to calculate the pressure in kilopascal now, but it is 20 Pascal. So I know that 1000 Pascal equals to 1 kilopascal, right now? 1 kilopascal, kPa. So thereby 20 Pascal will be how many? So 20 Pascal, that in terms of kilopascal is simply going to be, we are going to divide it now. So thereby you have got 20 Pascal divided by 1000, right? 1000. So this zero cancel, and here we have got 0 point, how much? 2 divided by
200
100.
PA.
2 zeros, no. We should be getting 0.0 and 0 and 2.
0
Sorry, 0.02 only.
0.002.
0.02 only. That's the same value which you got, Mustafa, right?
Yes, sir.
So that is 0.02 kilopascal.
So I got 0.020. Is that the same thing?
It's the same thing. Like if you have got a decimal digit, okay, no matter how many zeros you put after that non-zero decimal number, it's going to be same. Okay.
Okay.
Huh. By the way, Hanvi and Mustafa, you guys tell me. I'm assuming that both of you must have by now memorized tables till 20.
Yes, sir.
You have memorized tables till 20 or not?
No, sir, only not till 10.
What? Till 10? That's
I
not good,
know till
Hanvi.
10.
No, that's not good. I will talk to your maths teacher. You're taking the mathematics classes also from Learnivio, right?
No, sir, they're over.
It's over? Okay. Make sure you memorize tables till 20 because your maths is a little bit weak. Mustafa, what about you? Have you memorized tables till 20?
Sir, I know till 15.
Till 15? No, you are also going to memorize it till 20. Okay, because like even in science, at some places you have to do some numerical problem. Okay, na?
Okay, sir.
So
But I
multiplication,
know
division
till 13, sir.
till 13. Okay, see, table is, it's not a very big deal. Basically, the reason why it is advised to memorize tables till 20 because it helps you in doing mathematical calculations. It saves up lots of time in doing mathematical calculations. Okay, now that's why I'm saying it. Now, further in the upcoming classes, we'll be learning about pressure in fluids. Fluid here is a term which is basically referred to gases or liquid. By fluid, what we mean, gases or liquids are called as fluids. So, about the pressure in the fluids and in the gases, an important thing to be considered is that the pressure is exerted in all the directions. Okay, it is exerted in all the directions. So in the upcoming class, we'll be learning about that. We'll be learning about some activities also. So what you guys are going to do right after the class, you guys are going to open these activities from your book, read activity 11.8, 11.9, 11.